Proton Torch, Counter Radioactivity Tooling. This technology is at Readiness Level 5, validated in relevant environment. On 2011 March 11, the Big One came upon the Japanese coast, leading to the worst-known nuclear situation. 3 nuclear reactors had molten, one equipped with MOX, mixed plutonic oxides, the most radioactive, toxic, and explosive nuclear compound known today. Humanity is such made that despite the 1986 precedent, no lessons have been learned from Chernobyl. Moreover, the number of nuclear reactors worldwide remained at 430. No critical response plan exists, and global research on waste management stopped in the 1970 years. Facing with this situation, the ExoLab presented on 2011 April 25, the Procedure 128, built in the Daiichi's Intervention and Dismantling Plan, administered by the International Research Institute for Nuclear Decommissioning, and managed by the Mitsubishi Research Institute, with the Japanese Ministry of Economy, Trade and Industry. In this video, we will look only on the Proton Torch technology. We point that, although the ExoLab is registered in France, the agreements initiated between the Japanese authorities and the ExoLab are exclusive. In no case the French government and its relative entities was allowed to discuss or trade the ExoLab technologies. As said above, the management of radioactive compounds is worldwide a lower priority than the creation of the next mobile phone, as it was chosen to burying the nuclear waste underground in awful condition. Humanity is unable to remember what happened in the last 4,000 years, but claims to be able to protect all life forms and maintain nuclear burial facilities for over 100 millennia. Following COP21 and the massive promises for solar panels and wind generators solutions, the next generation of power plants will be more radioactive, more unstable, and many projects are projected unconsciously in the natural vital resources zones. MOX reactors, radioactive pressurized or boiling reactors. Located in subduction zone or on marine platform, to plunges the corium under the abyss and let the water disseminate nuclides over the world. Anyway, the treatment of radioactivity is never seriously pointed, even in emergency. This is why the ExoLab developed the Proton Torch. Like any linear particle accelerator, the energy expended between the 2 electrodes can reach the level needed for nuclear transmutation, whether splitting heavy atoms or fusioning light atoms. The proton torch thus consists of a specialized ceramic structure, a rapid hydrolyzer, a plasma linear accelerator, a pion generator, an X-ray generator. In action, it projects a stream of protons and oxyons on the target, with the energy of 210 MeV, which is the energy of uranium-235 in decay. The interest is that heavy atoms are transmuted to the lead state. The gases are fusioned in fluorine state whose half-life is less than 2 hours. This means that in a confined area, products as effluents will be completely stabilized in 600 days only, compared to the thousands of years needed in a static storage. Now here is the simulation of an automatic layout. Proton torch is fueled by meti.go.jp. The waste is poured into the inlet funnel where solid and liquid are crushed, then they are wet and mixed to form a creamy mud, without being too fluid. The valve opened, mud sweeping the gutter at low speed. To move into the torch enclosure whose are 60 degrees oriented, to optimize the transmutation. During the process, projections are collected by a funnel. At this time, the transmutation is effective, and sludge continues its descent for at least 4 seconds, until a Geiger sensor trigger the back route if the radiation level remains too high. The return is simply a baler, leading to wetting tray. If successful, the latch door is closed and the liquid goes to the final tank. It can then be decanted. Water is reusable. We specify that in optimal conditions, each proton torch is able to process 1 liter of radioactive material per second, meaning 3.6 cubic meters per hour, and 86.4 cubic meters per day. This video is now complete. Feel free to comment and share. It was the ExoLab, August 10, 2016.